Now we are discussing the vectorized implementation for the deep neural network. So first we have considered for the single training sample, and then from this we are proceeding to the M training samples. Now this small x is replaced with the capital X. As we already discussed, this Z1 is giving the activation units Z value of first layer for a single training samples. Means this Z1 matrix size is 3 by 1. But this Z1 matrix size is 3 by M. Means this capital Z matrix is consisting of M layers, or we can say M columns. So this is giving M columns. So in each column we are getting, this is the first training sample, second training sample, and mth training samples first layer Z values. Okay, by using these Z values, we will calculate the activation function. But now we will see the matrix sizes. What is the W1? As we discussed, the W1 will not change even if we give the single training sample or even if we give the M training samples. The W1 size is same as N1 by N0, number of activation units in the first layer, and columns are number of activation units in the 0th layer. Now what is this B1? This B1 already we know, number of activation units in the first layer, comma 1. Now what is this X? Number of activation units in the 0th layer, which are nothing but features, and comma M. Now the problem is coming. We are multiplying these two matrices, so the resultant matrix is N1 comma M, which is telling that the number of activation units in the first layer, comma M. But B1 is only N1 by 1. How can we add N1 by M matrix with the N1 by 1 matrix? On paper, in matrices, it is not possible. But we already discussed the concept of the broadcasting in the Python that will allow us to add this N by 1 matrix with the N by M matrix. So by using to use the broadcasting, the number of rows should be same, number of rows are same, and the number of columns in the second matrix must be 1, because it is satisfying the broadcasting principle. So the same number of N1, whenever we are taking the same number of columns will be replicated, and that matrix N1 by M broadcasted B is added to N1 by M in the vectorized implementation of deep neural network. That's how we are getting N1 by M matrix for the Z. By using this N1 by M matrix of Z, we are calculating the activation units. Because the Z matrix is having N1 by M, the A will also, the activation units of the first layer will also having N1 by M, where the rows are indicating the number of activation units and the columns are indicating the particular training sample we have given. So a common notation for ZL and AL are now the matrix notation for ZL and AL for single training sample NL comma 1 means the number of active. It is a simple point. Whenever we are having only 3 activation units, if we want to find the Z, we will find the 3 by 1 matrix. The Z is the Z we are using is a 3 by 1 matrix. Now when we want to find what is Z2, this Z2 is nothing but 5 by 1 matrix, because we are only applying the Z for these 5 units. Similarly, for the mth layer, depending on the number of activation units in that mth layer, nm by 1. So for the lth layer, nl by 1 for a single training sample. If you are taking the m training samples, then remember, if I am taking the m training samples for this first layer, then the z value is, first we will get the 3 values for the first training sample and another 3 values for the second training sample and another 3 values for the third training sample, like that another 3 values for the mth training sample. Now the Z matrix size will be 3 by M matrix, means the number of activation units in the Lth layer by M. So this is what we denoted here. The ZL and AL are a number of activation units in the Lth layer, comma, M matrix. If the L is becoming 0, means it is indicating the input layer, then the activation units are our input features only. So as we already discussed, the ZL and AL are NL by M matrices. The DZ and DA are also NL by M matrices, where DZ is the differentiation of the cost function with respect to Z, and DA is a differentiation of the cost function with respect to A. We already discussed the differentiation of the cost function for the sigmoid function. If we write dz of some 3, it is nothing but a3 minus y. We already derived it. So whenever we are saying dz, it is indicating that the differentiation of the cost function with respect to z. To find the differentiation of the cost function with respect to z, first we are finding differentiation of the cost function with respect to a, and we are finding differentiation of the a with respect to z. It is giving the differentiation of the cost function with respect to z. Simply we are denoting this as dz. So we have completed the forward propagation, and we have come to know how to implement the vectorized version by using the forward propagation. Even if we want the 1,000 layers are there in the neural network, we can now know the technique to find the 1,000th layer activation units by using the vectorized implementation.